Here is a strange pair of facts about tuples. Once you build one, you can never change what is inside it. Not one element, not ever. And yet you are completely free to point its name at a brand new tuple whenever you like. Both statements are true at once. Today we untangle that puzzle, then nest tuples inside tuples and loop straight over their elements. Take a tuple with 3 elements, the integer 2, a short string, and the integer 3. Suppose you decide the middle element should be a number instead. You reach in and try to assign a new value at index 1. Python refuses. It raises a type error and the message is blunt. A tuple object does not support item assignment. This is not a warning you can ignore. The assignment simply fails. Tuples are immutable. Once the object exists, none of its slots can be overwritten. Lists, which arrive in the next video, will happily allow this. Tuples never will. Why can't you change it? Because immutability is not special to tuples. Think about the integer 5 sitting in memory. There is no operation that turns that 5 into a 6. If you want a 6, you make a new integer. The same is true of strings. The characters inside a string you have already created can't be swapped out in place. Tuples join that club. You can always build a fresh tuple out of an old one, but the original object, once created, is frozen. Creating new values is easy. Modifying an existing one is what tuples forbid. Here is the question that trips people up. If tuples can change, why is it legal to write t equals some different tuple? The answer is that name and the object it points to are two separate things. The name t is just a label. Assignment with the equal sign doesn't reach inside the old tuple and edit it. It simply moves the label t, so it now points at a new object. The original tuple is untouched. It still sits in memory exactly as it was. You have only lost your handle on it. Rebinding a name and mutating an object are completely different acts, and only mutation is forbidden. Now something tuples can do that strings cannot. An element of a tuple can itself be a tuple. Build a tuple whose parts are the integer 2, a string holding just the letter A, the integer 4, and finally a small tuple containing 1 and 2. Ask Python for its length, and the answer is 4, not 5. That surprises people because the last part clearly holds 2 numbers of its own. But at the top level, we only count slots, and that nested tuple fills exactly 1 slot. What lives inside it doesn't change the outer count. 4 elements, and the 4th happens to be a tuple. Because that 4th element is itself a tuple, you can dig deeper into it. Read the expression left to right, indexing our tuple at position 3 hands back the inner pair 1 and 2. That result is a tuple, so you can immediately index it again. Adding a second index of 0 pulls out its first element, the number 1. 2 index operations chained together, evaluated one after another. Slicing behaves exactly as it did with strings. Instead of a single element, a slice hands you back a smaller tuple. Grabbing positions 0 up to 2, for instance, returns the tuple 2 and the letter A. Finally, you can loop over a tuple just as you looped over a string. A for loop does not hand you index numbers, it hands you the elements themselves. Writing for e in our tuple makes the loop variable e take on each element in turn. On the first pass, e is 2. On the second, it is the string A. On the third, it is 4. And on the last pass, e is the whole inner tuple, 1 and 2. Print e each time, and you'll see those 4 values appear in order. The only new thing to keep in mind is that an element handed to you might itself be a tuple, or any object at all. So tuples give you 3 lessons. First, they are immutable. Once created, no element can be reassigned, and the Python raises an error if you try. Second, rebinding the name is not mutation. Pointing t at a new tuple is always allowed. The old object simply loses its label. Third, tuples can nest, so a single element may itself be a tuple, which lets you chain indexing and slice just as you did with strings, and loop directly over the elements. Every move here was a string move you already knew, now working on a richer container. To practice what you just learned, this course has free exercises and AI-graded feedback on Ludium.ai. The link is in the description.